So let's welcome Vince back. Vincent back to B-Sides, and stage is yours. And afterwards, we'll go having drinks. Again, it's just a reminder, if you won't come back to the venue and you don't want the badge, do not throw it away. Please leave it at the desk. Thank you.
All right. Hello, everyone. I'm Vincent. I work at SourceGraph. I work on the security team. You might know us from Code Search or from the Agentic Coding Agent app. And today I'll be talking about building agents. I think there are many people who like to work with agents, but I don't know how many people actually wrote their own agent. And that's what I want to talk about today, because I think it's very easy to write your own agent, especially with all the coding tools available. You don't need to buy like an expensive vendor product that makes all sorts of promises, and you don't know how to handle your data. So if you write one from scratch or with some SDKs, you can also build a very, very good agent. My colleague Thorsten, he wrote a blog post in April of this year where he basically already explained how to make an agent from the ground up using the Anthropic SDK. It's a really good blog post. I'll be running through parts of his blog post during the talk, as he just explains really well how to build an agent. And then from the basic agent, we'll just add some tools, and then I'll show you with some demos what your agent can look like and what it can do and what you might not, or what you do want it to do. So yeah, great post, read it. It's definitely worth your time. So basically a small primer on what are LLMs again. I think many explanations have already been there, but just in case you don't know, it's basically a large machine learning model that they gave lots of data to, like books, blog posts, YouTube videos, whatever they could transcribe and dump it into a model. And essentially, you have something that can speak text and language and understands us. And obviously, they got all that data through legal means, as good citizens should also do. So commonly, I guess most people use chat-based AI agents, or just chat, right? You talk into a prompt, you press enter, you get your output, you download the image, or you download whatever generated, you paste it into a file. And yeah, that's actually the first iteration, right, of LLM usage. But yeah, we'll be writing an agent. So if you want a basic chat-based agent, you can use the Anthropic SDK, and basically you can, basically define a little buffer where you can get input from. You add the input function to the constructor, right? And then you add your prompt over here. Then you wait for the user to submit input. You add that to the beautiful Anthropic SDK, user role, JSON structure. You run inference, and then boom, you go over the output and you have a chat-based agent. It's like maybe 40, 50 lines of code, and you have your own agent. But yeah, someone thought, of course, like, hey, what if we give this thing tools? What can it achieve? Maybe it can like do work for us, so we can automate ourselves out of our job. So yeah, LLM is of course text-based, and LLM tools are also defined as text. So as you can see on the left part, I hope you can read it. You can easily define like, a tool function in JSON. You get the tool name, you get the description, the function, and the parameters. And then when you call inference with your tool inside the prompt, right? Because we'll have to add that to the prompt. The agent can then see like, oh, the user asks about the weather, so then it infers like, oh, maybe I should give it an accurate weather reading. I have a tool for that. It can then call the tool, and then your code will then, of course, return the weather. And then the agent comes with a nice little message to tell you what's the weather. In code, it would look roughly like this. This is from the blog post of Thorsten. You have your tool definitions at the very top. And then, of course, you have a very safe read file to actually execute the tools. You have some schema shenanigans, right? Because we need to send all that JSON and all the information to the prompt, to the LLM. We run inference, and of course we add the tools to the prompt. And then when we run inference, we can actually execute the tools and of course get the nice AI response back. So for security, like why would I want to make an agent? Well, input processing that an LLM can do, it's like really fast. It can infer knowledge or meaning from logs or pieces of text just really fast, much faster than I can, and probably also faster than you can. And most of the query languages and alerts that we have, they're all text-based, right? You have training data to train your new employees on how to work with these tools. You probably have playbooks on how to investigate certain tools. And yeah, the query is, of course, probably text-based as well. And for me personally, if I have to like look up an issue, like, oh, someone logged in from a new location, they have to grab data from 7 data sources, it gets a bit boring after a while. So yeah, like I previously said, you probably have all your playbooks and rules in text. This is an example of a playbook we have at SourceGraph. When someone logs in from an unknown location with a service account, this rule fires. We already had some human instructions that humans could, of course, follow to find out who used the service account. And I just added some agent instructions to there as well. So if my agent sees this alert, it just knows that it can run this query, and then it gets like the impersonation event for that user in the GK audit logs. And then it can cross-reference itself with some other data sources and can then tell us who did this, why they did this. That's actually pretty cool. So yeah, if you have any cheat sheets or any type of information on how to use indexes at your work or databases, you can all compile that into the agent so it knows what to do. So yeah, some tools that we can give to our agent includes, of course, log searching. We want it to be able to run aggregations, right? If you don't want your agent to query like 200 lines of logs or 2,000 lines of logs, it blows up your context window, you lose lots of tokens, lots of money real fast. You want it to be able to find open alerts. I also added functionalities to the agent so it can close alerts on my behalf. I also have some additional context from other data sources, like, but you can add anything you want. You can use the OTX database to make it query certain indicators of compromise. You can make it do whois for you. Query metadata from your Google Cloud environment or your AWS environment. All sort of things that you might not put into your SIEM, but of course a human would use. But of course, with tools come prompts, right? And with prompts, the context window increases. And what researchers have found is that the more tools you add, the more context you add, the more prompts. And then, of course, what happens if the context size becomes too big? The performance of the LLM model declines. So if you're using MCP servers, for instance, they come with lots of tools, and they also have lots of documentation for your tools. And if you only use one function from your MCP, you still get maybe like 10K tokens or 20K tokens, sometimes even 200K tokens inside the context window. That kind of ruins the LLM. So yeah, you have to think about context management, of course, or context engineering, as they want to call this, when you work with language models. So yeah, I kind of detest using web UIs. Back when I started as a pen tester, because I'm old now, everything was terminal-based. We used SSH and Netcat, whatever. Nowadays, I do my job in a browser, and I find that very unfortunate. I find the Elastic UI to be difficult to use. It has lots of information. It's not customizable as I want it. So I decided to write a CLI, and we're using Go. Then we have like the amazing bubble tea framework we can use. We can, of course, use some Go SDK, and the Elasticsearch SDK as well. So this is an example of the agent tool that Elastic provides us with. I think it looks absolutely horrible. It's too much information. I don't know. I don't even know how to use it. Somewhere I can type, I guess, and then press enter, and it's going to do some stuff for me. It also comes with research summarized for you if you want that. Like I don't even know they had a blog, but apparently they do. So yeah, that is not what I want from an agent, right? I want something minimal that follows my instructions. I type a query. I type some text. It runs a query. It summarizes the output for me. That's what I want. Incredibly lazy. So yeah, how would you implement some security tools? Well, of course, you have to start with metadata, right? You have to tell the AI, all right, you want to run an Elasticsearch query? You give it the index, give it a query, default fields, we define all that, just like we saw in the example from Thorsten. And we, of course, have the actual implementation, right? This is what the model will call. The input from the model ends up there. We do some input validation, and then essentially we just call the implementation of our interface. In my case, it looks like this because it's, of course, Elasticsearch. So here it can just do a simple query string. It knows about Lucene. I'm using Anthropic SDK. It knows Lucene. I don't know how they know, but yeah, probably trained on a ton of data. And so it can just run queries fairly easy. We call Elasticsearch over there, and then we just return the JSON to the agent. because I don't want my agent to start like searching in my SIEM and look at open alerts because the context window explodes. For getting open alerts, we have a predefined tool, and we can have more predefined tools that basically always gives back the open findings. Because you don't want the agent to do that for you because they get creative. They might not do always the same thing. You want everything to be reproducible. So yeah, the input in this case, of course, is not used. Yeah, this is how it looks like. It's a simple call to Elastic. Of course, there's a transport that adds some tokens and some rate limiting, but in the end, it's a couple lines of code. And now, yeah, we put it all together, right? When we want to use our agent, we have to give it the tools. This builds everything up. The SDK we're using, it has some odd things that I have to define to be able to have memory. When I first used the SDK without setting this up, it was just always, yeah, only one message each. I don't know, it didn't keep track of the previous messages. And then we just add that to the agent, and that's it. This SDK that we're using, the NGINX SDK, it comes with plan approvals. Our agent is relatively simple, and we use it in supervised mode. So we don't do approvals. We just let it execute tools when I ask it to execute tools. To put the TUI together, of course, we define a basic logger. We have an agent constructor that we give the logger. And then we have a submit function, much like the one from Thorsten, but now only it looks a little bit fancier than the example one. And of course, when events come back from the TUI and from Anthropic, we need to put the information back in the user interface. And here we actually create the CLI. So yeah, what does it actually look like when we're using this, and is it any good? Nice, this actually works, cool. Because I'm old, right? Doing live demos gets my heart rate up. I'm already using Linux, so I don't know if my display is gonna connect or not. So I recorded the demo. I set up an Elasticsearch cluster for this demonstration. And in the Elasticsearch cluster, I've done some nefarious things. I created a service account, an editor in one of the projects. I downloaded it on my machine, and I took some actions and triggered some alerts. And the agent now is going to investigate that for us. First, I'll show you the open alerts. I also made a demo for that. I'm sorry. It's just to show you what the UI looks like. It's a bit tedious. You have an investigation guide. It is rather large, but it is comprehensive. And then when you want to look at the data there, you have to basically scroll down a bit. Of course, the alert that you give it in Slack, it has some more information, but here, yeah, it's just a bit too slow for me to find out what's going on. And the overview doesn't really show much. The table is a bit annoying to use. But yeah, it gives you all the information that you want, essentially. Now I need to go back and click the actual agent demo. So yeah, I'll run the agent here. Type a question like, what are the open alerts? It starts thinking, of course, because it has to think. It gets the open alerts in this case. There are 2 pod exec alerts, and there's 1 account creation alert. And then, of course, it needs to think. Of course, it has a bit of, yeah, it like one of the audience members said today, it likes to think alerts are more critical than they are. The Kubernetes execs and the key creation, they are low. Like severity is low, it's defined as low, but it does say like, yeah, this is a high risk. You can tweak that out in a prompt, so it's less creative. But yeah, now we see it actually, go through the logs. It found my IP. It's looking for the timestamps, the right ranges. It then found my user, and now it's going to see what this user did. Well, it already found service account key creation. And the thinking, of course, is things very hard. That's what we wanted to do. If you tell Anthropic to think hard, the models will actually think hard. I don't know what it means, but that's what it does. I think it's now summarizing the findings. Of course, I'm connecting to Anthropic USA from Portugal, so it's a little bit slower. So yeah, as you can see, it gave a pretty good overview. It does classify it as, critical, right? It says like, oh, someone did a privilege escalation. A user downloaded a service account key, put it on his machine, ran some commands. I used the Kali Linux one, which of course for the LLM is a little bit alarmist, right? But overall, the assessment is solid. Those are indeed the actions that I did. You can look at the logs. It confirmed malicious. Yeah, I know. I don't know how it confirmed. It didn't ask me if I did this maliciously, right? So yeah, you have to tweak that out a bit in the system prompt. And this is, of course, from my demo tool, the one that I built open source for this presentation. But yeah, overall, it does a really good job at explaining what happened based on the logs. Yeah, now I wanted to close the alerts, right? Because I was pen testing in my project. So yeah, I tell it to close the alerts, and it does so. And that's pretty much it. I'm just curious, like, how many folks use an agent like this at work, a security agent? I don't see many hands, but I see a few. All right. Yeah, now it will call the tool again to verify if everything's closed. But yeah, that's pretty much it. And that is not what I wanted to do. Okay, cool. So yeah, that's it. In my work, of course, there are more data sources in our Elasticsearch cluster. This is like an overview of what a real example would look like of the open alerts. We have some MFA findings, some suspicious Google logins. I asked the agent to investigate the MFA findings. We recently moved to different YubiKeys, so lots of employees are changing their MFA. And it does a really good job of verifying if it was legit or not. Basically what it did, what I tell it to do in the prompt, is to verify whether those MFA deactivations are followed or before they happen, were actually authenticated from a managed device. Did they use their managed device? Did they use Okta? Did they use Okta Verify or a YubiKey before? And did they then also use YubiKeys after? And was it from a consistent location? And yeah, it actually answers that real quick. This is another comprehensive example that uses, like, I think, 4 data sources. We use Falco for some of our cloud runtime environments. And here I was doing some maintenance in one of our projects. So it triggered an event, like, oh, someone exec'd into a Falco pod. And yeah, here it combined data from GKE audit logs, from Falco logs, okay. And also because we use just-in-time permissions at SourceGraph, which we'll talk about a bit later. It can also go to that data set and be like, okay, at the time of this event, what permissions did Vincent have? And yeah, it found 3 black boxes of permissions, but essentially it's the permissions that I required for tweaking the configuration of the customer instance, and someone from my team has to approve that. So yeah, once it knows all that, it's very easy for it to make a good judgment of whether it was malicious or not. And yeah, yeah, Vincent had all the vetted entitlements, used regular IP addresses, looks legit, which I think is pretty useful. So as I mentioned before, like, our agent can access information about our real-time permissions. It's just because we use entitle, which is a permission system. So basically, let's say I want to access a cloud customer instance, I need to select the permissions. I need to enter, like, why I want to access, how long I want to access. And the moment someone approves, it registers in our system, and we query that as part of our agentic loop. Of course, we have Okta logs and device management logs. They're always good to have a look at. And 1Password, audit logs, like audit logs, you name it. All those data sets are very useful. We also gave it some tools to talk to GCP, because most of our projects have random names. So we don't know what customer it is, or we don't know what service account is used for, because we have to read the description, and the agent can then call some APIs to get that information. People like talking about guardrails. I think it's good to have some guardrails for your agent. The SDK that we're using has content filters, PII filters, tool execution blocking, lots of things. Personally, I think filtering is not a very good option, because if the LLM wants to, or if someone wants to submit PII, they can just slightly change the format, right, of the PII, and then your filters wouldn't catch it. So it's kind of like a cat and mouse game. What I know with my colleague who added secret redaction is that the better your secret redaction will be, it will also be more false positive prone, right? So it can also just ruin the experience. So if you want to use LLMs, make sure you are authorized to use it on the data instead of building other guardrails into the tool. I also am not a big fan of using agents with privileged access in the background. People like asynchronous agents. Well, when it comes to security work, I just like to have like a chat buddy, right? I chat, I say, hey, look at these alerts. It looks suspicious to me. I just keep it under close supervision all the time. Our agent can also write Falco rules for us because Falco rules are simple text-based. Sometimes something changes in one of our base templates of the images, and then I know it's a false positive because I wrote the rules. I can tell the agent, look at this alert, update the Falco rules, and then I check the diff, and then I submit, and then everything's fixed. It's just very tedious to do this by hand, and with an agent, it's much easier for you to be on top of your rule sets. I'm already over time. I thought I was talking really fast, but I had lots of slides too. If you want to give the agent file system access, either use the sandbox or use path reversal resistant file APIs, because agents are creative. And if there's a little bit of a prompt injection risk, better safe than sorry. My agent cannot create files. It can edit files and read files. But yeah, it's fairly limited. If you want to prompt your agent to close alerts and then you have another approval box, that is very tedious. So I took that out. So the agent can close alerts when I ask it to, or when someone prompt injects me in like a user agent header, I guess. Yeah, I tried using this with Olama and Quen. The quality of the agent is not as good. Also because the tooling is not as mature. I'll keep experimenting with it and hopefully I can get it into a better state. If you can't code, just download my example. Let an AI, right, implement the interfaces for you. All the data is out there for most SIEMs. I quickly let it implement something for Panther. Panther has view as markdown for the API. You click that, you give this to your agent in a URL, you give it a prompt, it looks at the examples of the code that's already there, and then it just, yeah, you grab a coffee, right? Because you let the agent do its job. And then when you come back, it wrote the code for you. If you don't know how to code, you should do that. If you do know how to code, be a bit more specific and give it some good examples. And it's 13 cents. It's not super expensive to do so. Yeah, that's it. What I want you to take away from this talk is build your own agent, see what it's like. It's remarkably simple. Of course, before you use it in a professional environment, make sure your legal department agrees with you shipping these things to an LLM provider. Trust but verify. Allow the agent to do things. But please, yeah, verify if it's yelling about an incident, but it's just me pen testing. And yeah, code is cheap. You don't need to be a super software engineer to start writing code. You need a basic understanding of what code should look like. And of course, as a pen tester or a security person, you should test your changes. That's it. That's the talk. And any questions? No questions? Oh, no. Cool, time for a beer, I guess.
Thank you, Vincent. Thank you, everyone. So you can have